Everyone is obsessed with NVIDIA, but they're looking in the wrong place. Because the biggest bottleneck in AI right now isn't the chips, it's heat. The problem isn't intelligence, it's thermodynamics. We're building the most powerful brains in human history and trying to keep them from overheating using a method that hasn't fundamentally changed in over a century: moving air. For decades, that worked. Servers got hotter, we added bigger fans, more airflow, more space, more power. But AI isn't scaling like that. It's compressing power into smaller and smaller spaces, and heat doesn't scale politely. Air cooling is hitting its limits, and when heat can't escape fast enough, performance drops, systems throttle, energy costs spike. At scale, that's not a technical issue, it's a financial one. The industry is approaching a breaking point, and a small group of companies is positioned to benefit from what comes next. And whoever solves that doesn't just participate in AI, they tax it. They sit at the point everybody has to pass through. This is what I call the liquid moat. You need dielectric fluids, engineered liquids with very specific properties: non-conductive, thermally stable, and reliable under extreme conditions. And only a limited number of companies can produce them at scale. These tend to be specialty chemical companies, the kind that already manufacture high-performance industrial fluids for semiconductors, energy systems, or advanced manufacturing. Businesses that operate quietly, but sit deep inside critical supply chains. Most investors look at AI and think about software or chips. But when a system hits a physical limit, value shifts. It moves toward whatever removes the constraint. And right now, that constraint is heat. Because intelligence doesn't run in isolation. It runs on physical systems: power, materials, cooling. And when one of those breaks, everything slows down. The chips are getting more powerful, but the systems around them are struggling to keep up. And when heat can't be removed fast enough, performance drops, costs rise, density stalls. So the bottleneck is no longer compute, it's the environment that compute depends on. And when that happens, the leverage moves. Not to the surface, but deeper into the system. And that breaks down into 3 layers. First, the fluids. These aren't just chemicals, they're gatekeepers. If large-scale AI depends on immersion, these become a required input. And if they fail, everything fails with them. Second, the systems. This is where infrastructure gets rebuilt: flow control, heat exchange, material design. And infrastructure is where long-term capital flows, because once it's built, it tends to stay. Third, the operators. The data center providers adopting this early. They don't control the moat, but they gain efficiency first. And in markets, early efficiency becomes advantage. And once that shift starts, it doesn't reverse, because efficiency becomes expectation. So what we're watching isn't just AI growing. It's a constraint forming. And every time that happens, value shifts. Right now, that constraint is heat, which means the advantage is moving away from what's visible and toward what everything depends on. Because AI doesn't just need intelligence, it needs cooling. And the companies solving that sit underneath the entire system. If you want to understand where these structural shifts are happening before they become obvious, this is exactly what I break down on this channel. Subscribe. Thanks for watching.